at finding the maximums and minimum values of a curve, which this is one of those things that where we want to find the zeros. And so without doing the calculus, we quickly talked about it in class when we did the secant lines. We talked about, okay, to find tangent lines, you actually have to use a derivative. So using calculus, we go from a function into the derivative of that function, okay? And again, if you want to be able to do this, the idea was taking the exponent multiplied by the coefficient and reducing it by 1. That's basically what they're doing here. But you don't have to do that. It's already given to you. Okay, so they're going to say, given this function, I want you to find the zeros of the first derivative to help find the max and mins. Because the first derivative actually gives you the instantaneous rate of change of the curve. And so where the curve's slope is 0, we'll kind of quickly just look at what's going on here. We've got a fourth degree function that's going to kind of look, let me see if I can guesstimate what it looks like. I think it looks something like that. Anyways, you're going to type in the calculator and let it give you a more specific look. But if I kind of remember correctly from the answers first period, this is roughly what it'll look like. I want to find where the max and mins occur. And so since we're looking at the instantaneous rate, which is that first derivative, the slope of this curve is 0 at the very bottom, where it goes from negative to positive. And it's also at 0 when it goes from positive to negative, so at the top. So what we're looking for is the zeros of the first derivative, which will give us these max and min values at the top and bottom of these curves. And so we're not actually looking for the zeros of that function. We're looking for the zeros of the slope of that function. So what we're going to take a look at is the same idea. We've got first one we always like to check is 1. And so 4, negative 18, 2 and 24. If we do that quickly and we add across the top, we've got 4 minus 18 is negative 14, plus 2 is negative 12, plus 24 is positive 12. Okay, that one doesn't work, so we don't have to worry about going through the synthetic division. Next one we could try is negative 1, because negative 1 is another good one to check. And so this one, we run through it, we get 4, negative 4, negative 22, positive 22, positive 24, negative 24, and 0. Yeah, that one worked. Okay. So we found one of the zeros, and now we're left with the quadratic. Sometimes to make factoring easier, you like working with smaller numbers. So if there's a common term, feel free to pull it out. In this case, there's a 2 we can pull out. And so we're left with 2x squared minus 11x plus 12. And so looking at the AC of this, we end up with 24. What's going to multiply to 24 but add to negative 11? Negative 8 and negative 3. Good. And so we'll split this b term apart. We'll end up with 2x squared minus 8x minus 3x plus 12. Okay, and that multiplied by 2 piece just kind of hangs out up front. Okay, it's just kind of there. We also technically still have this x plus 1 thing that's kind of there as well. But finding these other zeros, we're going to be able to factor this out. Will be a 2x. We're left with x minus 4. And then we can pull out a negative 3. And we're left with an x minus 4. That 2 is still kind of out front there. And so our other 2 factors are going to end up being the x minus 4 and the 2x minus 3. Okay, and then if we bring back in this 0 that we found up there, we'll see that we also have the x plus 1. So what this is telling us is the zeros of this function are going to be negative 1, positive 3/2, and positive 4. And so as we look at this graph, we're going to see that this value here is going to be -1 comma something. Okay, if you want to find what the true minimum is, you can take it and plug it back into the big g of x function. We know that this coordinate point is going to be 3/2 comma something. Okay, again, throw 3/2 into that function if you want to find where the actual max is, and then this should be at +4 comma something. Okay? And so all it's going to ask you to do once you find these zeros is verify in the calculator that it makes sense to your calculations. So you want to see that, does this tend to support your calculations? Do the maximum and minimum values occur at the zeros of little g? And so when you go and look, and we hopefully are all comfortable at this point going into our calculator and finding max and mins on curves. If you find the minimum values, you should see that the x value is -1. If you find the maximum, it should be at 1.5 or 3/2. And then the other minimum should be at 4. Okay, so that's what we're going to take a look at today.